A diver descended through the dark water beside a small Greek island and found the remains of a ship that had vanished more than 2,000 years earlier. Across the seabed were marble bodies, bronze arms, broken pottery, glass vessels, coins, and the scattered cargo of one of the richest ancient shipwrecks ever discovered. Among those treasures was a corroded lump of bronze and wood that appeared almost worthless. It was carried to the National Archaeological Museum in Athens and placed with the other objects recovered from the wreck. Then the lump broke apart. Inside it were bronze gears, not one or two simple wheels. Dozens of precisely cut gears had once turned together inside a box small enough to carry. Around them were dials, scales, pointers, axles, and thousands of tiny Greek letters. The machine could follow the movements of the sun and moon. It could display the changing phase of the moon. It could keep several calendars synchronized. It could predict when solar and lunar eclipses were likely to occur. It even tracked the cycle of major athletic festivals, including the ancient Olympic Games. And inscriptions suggest that its missing front display may have shown the movements of all 5 planets known to the ancient Greeks. The object is now called the Antikythera Mechanism. It was built more than 2,000 years ago. Nothing else like it survives from the ancient world. The wreck lies off Antikythera, a small island between Crete and the Greek mainland. The surrounding sea can become violent without warning. Strong winds pass through the region, while steep underwater slopes fall away from the island's rocky coast. Sometime during the 1st century BC, a large ship carrying luxury goods entered these dangerous waters. Its exact journey is unknown. The ship may have been traveling west toward Italy, with cargo gathered from different parts of the Greek world. Then something went wrong. A storm may have driven the vessel against the island. The ship sank beside a steep underwater cliff, scattering its cargo across the seabed at depths of roughly 40 to 60 meters. For nearly 2,000 years, the wreck remained hidden. Then, in 1900, sponge divers from the Greek island of Symi stopped near Antikythera. They wore heavy diving suits with metal helmets. Air reached them through hoses connected to pumps on the boats above. One diver descended and found what first appeared to be human bodies lying across the seabed. They were ancient statues. If discoveries that reveal lost technology are why you are here, subscribe and turn on notifications. Because the strange bronze object recovered from this wreck would eventually force historians to reconsider what ancient engineers were capable of building. The sponge divers returned with support from the Greek government. Working in dangerous conditions, they recovered marble and bronze statues, jewelry, glassware, pottery, furniture pieces, weapons, coins, and parts of the ship itself. One of the most famous sculptures was a bronze figure now known as the Antikythera Youth. Other fragments belonged to philosophers, athletes, horses, and figures that had once decorated wealthy homes or public spaces. Compared with those objects, the corroded mechanism attracted little attention. It looked like a damaged block of material covered in marine growth. Its wooden case had almost completely disappeared. The bronze inside had reacted with seawater and minerals. Individual parts were fused together. Then cracks exposed gear teeth and engraved writing. Researchers realized they were not looking at an ordinary navigational instrument. They were looking at a machine. The surviving object is now divided into 82 fragments. 30 bronze gears can still be identified. Only about 1/3 of the original device is believed to survive. The rest may have dissolved, broken during the sinking, remained on the seabed, or been lost during the difficult recovery. The complete mechanism was probably housed inside a wooden case, approximately the size of a thick book or small portable clock. Bronze plates covered its front and back. A handle or knob allowed the user to turn the internal gears. Moving one input caused the entire display to change. Pointers rotated. Calendar dates advanced. The moon moved around the zodiac. Its visible phase changed from dark to light. Eclipse information passed through a long spiral scale on the back. The device was not powered by electricity. It contained no electronic components. It was not a computer in the modern digital sense. It was a mechanical analog computer. A user entered a date by turning the mechanism. The gear ratios then performed calculations physically. A large gear driving a smaller one caused the smaller gear to rotate faster. Combining several gears allowed ancient engineers to represent long astronomical cycles. A pointer might complete one revolution, while another moved only a small distance. By choosing the number of teeth on each wheel, the maker could translate mathematical relationships into mechanical motion. The result was a model of time and the sky contained inside a box. One of the most important cycles displayed by the machine was the Metonic cycle. Ancient astronomers knew that 19 solar years were almost equal to 235 lunar months. After that period, the phases of the moon returned to approximately the same dates in the solar year. The mechanism represented this cycle on a 5-turn spiral dial at the back. A pointer followed the spiral as the gears turned, connecting lunar months with the solar calendar. A second spiral represented the Saros cycle. Ancient Babylonian astronomers had recognized that eclipses repeat in a pattern lasting approximately 223 lunar months. The Antikythera Mechanism turned this astronomical knowledge into machinery. Symbols inside the spiral marked months when a solar or lunar eclipse might occur. Some inscriptions included information about the expected time and characteristics of the event. The machine could not see the future. It did not measure the sky while operating. It used repeating cycles based on centuries of observation. But to someone living more than 2,000 years ago, turning a handle and seeing a future eclipse appear on a dial must have felt extraordinary. The mechanism also tracked a 4-year cycle linked with major Greek athletic festivals. These included the Olympic Games and other pan-Hellenic competitions. That function connected astronomy with public life. Religious festivals, travel, politics, and athletic competitions all depended on calendars. A machine capable of coordinating those cycles was not merely an intellectual toy. It could demonstrate how celestial order shaped human events. The front of the mechanism is more difficult to reconstruct because much of it is missing. Surviving inscriptions describe a display of the ancient Greek cosmos. The Earth stood at the center, according to the astronomical model used at the time. The Moon and Sun moved around it. Mercury, Venus, Mars, Jupiter, and Saturn may have been displayed in rings, each marked by a small sphere. The device did not show the true structure of the solar system as understood today. It showed the heavens, according to ancient Greek mathematical astronomy. Creating those planetary movements with gears was extremely difficult. A planet does not appear to move across the sky at one steady speed. At certain times, it seems to slow, stop, and move backward before continuing forward. Modern astronomy explains this apparent retrograde motion through planets orbiting the Sun at different speeds. Ancient Greek astronomers used combinations of circles to model the same observations. The mechanism's maker may have translated those geometric theories into rotating gear systems. Researchers studying the surviving inscriptions found numbers linked to the cycles of Venus and Saturn. Modern reconstruction teams have proposed tightly packed arrangements of gears capable of producing those periods. One major model published in 2021 recreated a front display containing the Sun, Moon, and 5 planets. But it remains a reconstruction. Too much of the original front is missing to prove that every proposed gear was positioned exactly that way. The back of the mechanism is understood more securely because more evidence survives. One of its most remarkable features modeled the Moon's changing speed. The Moon does not move around Earth in a perfect circle at a constant rate. Its apparent motion speeds up and slows down. The ancient maker reproduced part of that variation using a pin moving inside a slot attached to a rotating gear. As the parts turned, The pin shifted back and forth. This changed the output speed and caused the lunar pointer to accelerate and slow. It is a sophisticated mechanical solution. It shows that the builder was not only copying a simple calendar. The builder understood a mathematical model of irregular celestial motion and knew how to express it through bronze. The device also displayed the moon's phase. A small rotating sphere, probably dark on one side and light on the other, showed whether the moon was new, full, or somewhere between. As the lunar pointer moved around the front dial, the sphere rotated automatically. One movement represented the moon's location. Another represented how much of it appeared illuminated from Earth. All of this occurred through mechanical connections inside a case only a few centimeters thick. The inscriptions were equally important. The surviving fragments contained thousands of tiny characters, some hidden beneath layers of corrosion. Parts of the text acted like labels, others described astronomical cycles. The protective covers appear to have contained instructions explaining the displays. The machine carried part of its own user manual on its surface. For decades, much of that writing could not be read. Researchers used ordinary photographs, drawings, and early X-rays to study what they could see. The British science historian Derek de Solla Price spent years analysing the mechanism and argued that it was a calendar computer. Later researchers produced increasingly detailed models. A major breakthrough came in 2005. A powerful microfocus X-ray CT system was transported to the museum in Athens. The machine scanned through the corroded fragments and created images of structures hidden inside them. Gear teeth became visible. Previously unreadable letters appeared. Layers crushed together for 2,000 years could be separated digitally. The scans revealed that the mechanism was even more complex than earlier researchers had believed. Scholars began reconstructing entire lines from partial inscriptions. They identified eclipse information. They studied gear tooth counts. They found descriptions of planetary displays. What had looked like a corroded mass became a three-dimensional puzzle filled with mechanical evidence. Even now, researchers disagree about parts of the reconstruction. Different teams propose different arrangements for the missing gears and pointers. One study may interpret a fragment as part of a planetary display. Another may connect it with an eclipse cycle. A set of holes on a damaged calendar ring has been analysed using statistical methods to determine whether the original scale followed a solar or lunar year. Every answer creates another question, because most of the original machine is gone. The identity of its maker is also unknown. No surviving signature clearly names the engineer. The astronomical knowledge behind the device came from several traditions. Babylonian observers developed numerical cycles for predicting celestial events. Greek mathematicians created geometric models of the heavens. Skilled metalworkers transformed those ideas into precisely cut bronze gears. Some researchers have connected the mechanism's intellectual tradition with Rhodes, an important center of astronomy. Others have noted possible links with Corinth or Syracuse. Archimedes is frequently mentioned because ancient writers described celestial machines associated with him. But Archimedes died more than a century before the Antikythera mechanism was probably constructed. There is no evidence that he personally designed this object. At most, it may have belonged to a longer tradition of mechanical astronomy that included engineers influenced by similar ideas. That raises one of the greatest mysteries. Was the Antikythera mechanism unique? A machine this complex was unlikely to appear without earlier experiments. The maker needed experience cutting gears, arranging axles, engraving scales, and correcting mechanical errors. Someone had to calculate the tooth counts. Someone had to test whether the displays remained synchronized. Apprentices may have learned the process. Other devices may once have existed. Yet no comparable ancient machine has survived. Bronze was valuable. An obsolete or damaged mechanism could be melted down and turned into tools, coins, weapons, or statues. Wooden cases decayed. Thin gears corroded. Wars, fires, shipwrecks, and the recycling of metal erased most ancient machinery. The Antikythera Mechanism survived because it sank. The sea destroyed much of it, but the wreck also protected the remaining fragments from being melted down. This is where the most dramatic claims need to slow down. The machine is not evidence of aliens. It does not prove that ancient Greece possessed electricity, engines, or modern industrial factories. It was not more powerful than a modern calculator. It could perform a specialized group of astronomical and calendar calculations built into its gear ratios. It could not be freely programmed to solve any mathematical problem. Its front display remains partly hypothetical, and researchers still debate exactly how every surviving fragment functioned. None of those corrections reduce its importance. The real achievement is more impressive than the fantasy. Ancient engineers created a portable machine that combined generations of astronomical observation, mathematical theory, precision metalworking, and mechanical design. They cut tiny triangular teeth into thin bronze wheels. They placed gears on gears. They used pins, slots, axles, pointers, spiral dials, and engraved instructions. Then they fitted everything into a wooden case. The machine demonstrates that advanced knowledge can disappear without its creators being primitive. Civilizations do not always progress in a straight line. Skills can become too expensive to maintain. Workshops can close. Patrons can vanish. Books can burn. Specialists can die without passing on everything they knew. An invention may be admired for one generation and forgotten by the next. The Antikythera Mechanism did not sink because the ancient world rejected technology. It sank because the ship carrying it was lost. Its destination is unknown. The identity of the owner is unknown. It may have been an educational instrument, a luxury object, a demonstration of cosmic order, or a practical calendar calculator. It may have belonged to a wealthy Roman collector, transporting Greek art and knowledge westward. The wreck carried statues, glassware, pottery, furniture, coins, and other expensive goods. The mechanism traveled among objects worth preserving. Someone considered it valuable enough to place aboard the ship. Modern underwater teams continue investigating the wreck. They have mapped a much larger debris field than the first sponge divers explored. They have recovered additional fragments of statues, pieces of the ship, pottery, human remains, and objects hidden beneath boulders. Researchers continue searching for more parts of the mechanism. More than half of the original machine may still be missing. Some pieces could remain trapped beneath rocks and sediment. Others may have been carried downslope. There is even evidence that another ancient wreck may lie nearby, complicating the site further. A single newly recovered gear could change the reconstruction. A plate containing more writing could name the maker. A surviving pointer might reveal how the planets were displayed, but the sea may never return those answers. Today, the original fragments remain in Athens. Behind museum glass, they do not immediately resemble a computer. They look like damaged green-brown stones. Only when the X-rays, diagrams, and reconstructions appear beside them does the machine return. Gears begin turning. Pointers cross engraved scales. The moon changes phase. An eclipse moves closer. Athletic festivals approach on the calendar. The ancient sky begins moving again. 2,000 years ago, someone turned the handle and watched the universe respond. Then the machine was packed aboard a ship. The ship entered the waters beside Antikythera. It sank with its passengers, its statues, and the greatest mechanical device known from the ancient world. The wooden case disappeared. The bronze corroded. The name of the inventor was lost. But enough survived to reveal what the machine had once been. Not magic. Not a legend. A computer made from gears, built 2,000 years before anyone expected to find one. The next investigation is waiting on screen now.